Welcome back to our Advanced Apache Pinot series. I'm Victor Gamov with StarTree, and today in this video, we're gonna talk about how to speed up data retrieval and speed up your queries in Apache Pinot using indexes. I can call indexes a secret sauce that makes your queries run faster and more efficiently. And Apache Pinot has a variety of different indexes that you can configure for different data types. Let's jump right in. Indexes are just like fast lanes on the highway. They help you quickly find the data you need without having to scan through everything. In Apache Pinot, we have several types of indexes that you can use to speed up your queries. Let's start with a forward index. This is a default index applied to each column in Apache Pinot table. So you can think about this as a table of content in the book. When you know which chapter you're looking for, you can quickly find the page number, and forward index point to the value within a document that would be easy to retrieve. When dictionary is enabled, the forward index becomes a dictionary encoded forward index. If the segment is sorted by index column, it acts like a range index. Forward index are applied by default, so they will always on and they always there to help with basic data retrieval. Next is inverted index. Imagine you have a giant filing cabinet full of documents and you need to find every document that mentioned word organic. Instead of going through each document one by one, inverted index works like an index on the back of the book. So, like if you know the particular term, you will get a list of documents or pages where this term is mentioned. Implementation of inverted index comes into two flavors. It is either sorted inverted index or bitmap based index. When data is sorted, inverted index stores in a range, making range queries super fast. And when data is not sorted, Pinot use bitmap to keep track of which rows contains each value. Next is StarTree Index. Aggregations like mean, max, and count can be resource intensive, depends on the size of your data set. Think of the StarTree Index as a clever librarian who pre-summarizes the most commonly asked questions, so you can get answers without having to flip through every book. StarTree Index pre-aggregates frequently queried data while combining less frequently queries into star buckets. StarTree Index are perfect for scenarios where you need to quickly aggregate results without processing the raw data every time. For example, if you are often querying the average sales per month, the StarTree Index can be pre-computed for those values, saving you time and resources. Next up is Bloom filter. This is a probabilistic data structure that helps you quickly determine if element is not present in the set. Imagine bouncer at the club with a guest list. Bloom filter is like the bouncer who quickly tells if someone is definitely not in the list, but might occasionally let someone in who is not in the list. Bloom filter is great for quickly find the segments that definitely don't contain your data. This helps to speed up queries by eliminating absolutely non-matching segments very quickly. Now let's talk about range index. This index is a variation of inverted index optimized for range queries. It's very easy to imagine that you might have a bookshelf sorted by publication dates and you want to find the books published between 1990s to 2000s. The range index allows you to quickly locate these books without checking each other. To configure a range index, you need to specify the column to index. Pinot then creates an index that makes your range queries much faster. Range index is perfect for time series data or any data sets where you are frequently querying all sorts of ranges. So the next up is text index. This is custom text-based indexing engine combining the inverted indexes, providing the fast text search experience. Now, imagine in the library, you might have a bunch of different books and you need to find books that contain only specific phrases. By implementing text indexes, you can build this powerful search engine that allows you to find right books very quickly. To enable text search, configure field config list and the table index config for the columns you want to index. Once configured, you can perform complex text searches efficiently using text_contains function. For JSON data, we have Json Index. Of course, JSON is just a text. You can also apply a text-based index for this one, but it would be much better to use special type of index for JSON data that understands JSON strings, JSON objects, and some nested structure. So with this index, you will build a detailed map that will help you navigate through this JSON document. JSON indexes allow you to set maximum level of nesting, including arrays, and you can include different paths that needs to be searched during the query. With JSON Index, query complex JSON data becomes efficient and straightforward, and use of JSON match function to perform detailed queries in your JSON data. So next, let's move to our Geospatial Index. This index supports H3 geospatial data types like point, line, and polygon. Imagine you're trying to find all the restaurants within 5-mile radius. The Geospatial Index allows you to perform these spatial queries efficiently. Geospatial indexes are essential for applications involving locating data. They enable fast and efficient spatial queries, making them perfect for mapping or location-based applications. Recently, we add one very exciting index called Vector Index. This index uses hierarchical navigatable small worlds algorithms to support vector search of a float array or multi-value columns. Think of this as a sophisticated matchmaker that finds the closest matches on the dating app. The vector index helps you to find top k closest vectors efficiently. Vector indexes are crucial for applications involving machine learning or recommendation system where similarity searches are essential. Configure your vector index to retrieve top k closest vectors, making your similarity search fast and accurate. Indexes are a powerful tool in your Apache Pinot arsenal. They help you to optimize query performance and make your data retrieval blazing fast. By understanding and using the right type of indexes for your data and query patterns, you can significantly enhance your analytics capabilities. From here, I highly recommend you to go into Pinot Advanced Repository, where you can find indexes folder with Docker Compose and README file and all required script that allows you to understand how you can configure and use different type of indexes. So now, remember, forward index is default index pointing to the values within the document. Inverted index points to the document and a given value, efficient for filtering. StarTree Index pre-aggregates frequently queried data for fast aggregation. Bloom filter, it's a data structure for pruning non-matching segments. Range index optimized for range queries. Text index, it's the optimized for fast full text search. JSON index handles nested JSON structure efficiently. Geospatial Index supports geospatial data types for spatial queries, and Vector Index allows you to perform similarity searches in machine learning and AI applications. As always, if you're experiencing any issues of running those examples or labs, don't hesitate to reach out our community Slack in troubleshooting channel with your questions or your problems. And that is it for today. Until the next time, happy indexing!